All right, today we're going to do something a little different. We're stepping back from the code itself to look at the architectural blueprint. We're talking about the high-level strategy for how we build systems, specifically how the very connections that hold our software together can, ironically, become their biggest single point of failure. We're going to explore how a big shift in thinking can help us build systems that aren't just scalable, but truly, truly resilient. So yeah, let's dive in.
So let me ask you this. Just think about it for a second. We spend so much of our time building these connections, right? Making sure service A can talk to service B. But what happens when those connections are too rigid, too direct? What if, instead of a strong network, we've accidentally built a fragile house of cards where one little hiccup can bring the whole thing crashing down? You can almost picture it, right? On one side, you have this hardwired approach. It often ends up looking like a tangled mess of spaghetti, where every single piece needs to know the exact location and status of every other piece. It is incredibly complex and brittle. But on the other side, you have a discovery-less model, where components, well, they don't really need to know about each other at all. They just talk to a central hub. This explainer, right here, is the story of that strategic journey from chaos to order. And it's not just a technical tweak. It's a completely different philosophy of building software. Okay, so let's start with the problem itself. When you're first building things, connecting services directly seems so easy. It's logical, it's fast. But this approach, it hides what you could call an architectural tax. It's this hidden cost that you don't pay up front, but you will absolutely pay for it later in the form of failures, downtime, and just constant maintenance headaches. This right here is exactly what we mean by hardwired. Service A is, for all intents and purposes, physically and logically chained to service B. It has to know its exact technical coordinates, the IP address, the port number. Imagine you had to hand-deliver a memo to a colleague. This is like needing to know their exact home address, and you have to make sure they're actually home at the very moment you show up. If they move, or if they just step out to grab a coffee, the whole thing fails. Your delivery is a bust. And this is where the real pain starts. When your services are this tightly connected, a failure in one service just instantly cascades to all the others. It's like a domino rally. Both services have to be online at the exact same time for anything to work. And what about scalability? Forget about it. If you want to add a new service, service C, to also get that information, you have to go back and crack open the code for service A to tell it about C. It's rigid, it's fragile, and it's an absolute nightmare to maintain or evolve.
Okay, now let's look at the solution. This table lays it all out, comparing the old way, direct coupling, with the new way, which we're calling MOM-mediated. MOM stands for Message-Oriented Middleware, and it is the absolute heart of this new approach. Now let's really break this down because the after column, it's a total game changer. Look at connectivity. It becomes discoveryless. Your apps only need to know how to find the middleware, not each other. Availability? It becomes asynchronous. If a service goes down, the message just waits patiently for it in a buffer. Scalability is ridiculously high because you can add 100 new consumers and the original sender never even has to know they exist. And maybe most importantly, look at failure impact. It's isolated. A problem in one service doesn't cause a system-wide meltdown anymore. This isn't just a small improvement. It's a completely different way of thinking.
Okay, so we've seen the problem, this tangled, brittle mess of direct connections. Now let's talk about the solution, which is actually surprisingly elegant. And to really get our heads around it, we're going to use a really powerful metaphor. Let's really slow down and unpack this, because this one idea is the key to everything else. Imagine you're in a massive skyscraper with hundreds of apartments. Without a concierge, you'd have to personally run up to the 57th floor, apartment B, hope someone's home, deliver your package, then run all the way down to the 12th floor, apartment F, and do it all over again. It's inefficient, it's exhausting, and it's prone to failure. But with a concierge, you just drop all your packages at the front desk and walk away. You trust that the concierge, the expert, will handle all the complex logistics of delivery. You, the sender, are now completely decoupled from the receiver. This is exactly what message-oriented middleware does for your software. So now we can put a formal name to this idea. The concierge, that central front desk, that's our message-oriented middleware, or MOM for short. It's this dedicated piece of software that lives between our applications, and its only job is to manage the flow of messages, which lets our other applications focus on what they do best, their actual business logic, instead of worrying about the complexities of delivery. And using our skyscraper analogy, we can easily define the three main roles in this system. First, you have the producer. That's the resident who has a package to send. They create the message. Then you have the broker. That's our digital concierge. This is the software like RabbitMQ that accepts the package and figures out where it needs to go. And finally, you have the consumer. That's the recipient, the application that ultimately receives and processes the package. Producer, broker, consumer. Simple, clear, and most importantly, decoupled. And, the concierge idea isn't the only way to think about this. Think about a really busy restaurant. A waiter doesn't just run into a chaotic kitchen and yell an order at a chef. No, they put a ticket on a rail. The kitchen staff then pulls tickets from that rail whenever they have the capacity. That's buffering. Or think about a flight control tower at an airport. Pilots don't talk to every other plane in the sky. That would be complete chaos. They talk to the tower, the central broker, which manages the flow of air traffic and prevents collisions. All of these analogies point to the same core benefits: buffering, flow control, and decoupling. It's all about putting a central coordinator in the middle to manage complexity. Now, for our digital concierge to do its job well, every single package that gets dropped off at the front desk has to be labeled in a standardized way. You can't just hand over a shoebox with no address and expect it to get there. This standardization, this common format, is the absolute key to making a whole system of diverse applications work together as one. So every message is basically structured like a package with three distinct layers. Layer 1 is the networking layer. This is all the under-the-hood stuff, the connection details. Think of this as the physical roads and trucks the delivery system uses. You don't really see it, but it has to be there. Layer 2 is the metadata. Now, this is the most important part for our concierge. It is the shipping label. It has all the data about the data, things needed for routing, for tracking, for handling. And finally, layer 3 is the body. This is the actual stuff inside the package, your business data, usually formatted as JSO or something similar. And this brings us to one of the most critical ideas in all of messaging, the black box principle. Let me be really clear about this. The concierge, our broker, does not open your packages. I'm going to say that again. It does not care what's inside. It's a logistics expert, not a content inspector. The only thing it needs to read is the shipping label, that metadata layer, to know where the package needs to go. The content inside, the body, is a complete black box to the broker. It's private business data that the infrastructure doesn't need to know about and, frankly, shouldn't know about. And why is this so powerful? Well, because the middleware is totally agnostic to your business logic. You can change your business logic as much as you want without ever touching your infrastructure. The delivery system, the concierge, can stay exactly the same even if the contents of the packages change from sales orders one day to user notifications the next. This separation between delivery and content gives you incredible long-term flexibility. So let's just pause for a second and connect the dots. The real magic here is in the standardization. Because we've all agreed on this consistent three-layer structure for our packages, and we've agreed on a single protocol to govern it, we effectively create a universal language for all of our services to speak. This is how you finally, once and for all, break down those data silos between departments. It's how a brand new system written in Python can talk seamlessly to a 20-year-old legacy system written in Java. As long as they both know how to format the envelope, the technology inside doesn't matter. Okay, so we have our standard package format. But for a global delivery system to work, you don't just need a standard package. You need a universal rulebook, a protocol that every post office in the world agrees to follow. In the world of software, that rulebook is what lets us truly connect everything and break down those data silos across an entire company. And that protocol is called AMQP, the Advanced Message Queuing Protocol. You can just think of it as the official rulebook for our digital concierge. It defines exactly how messages are structured, how they're exchanged between producers and brokers, and how things like errors are handled. And crucially, because it's an open standard, it prevents vendor lock-in. As long as your Python service and your Go application both speak AMQP, they can communicate perfectly through the broker without any special translation needed. And because AMQP is such a rich and mature protocol, it supports all the real-world communication patterns that businesses actually need. Let's look at what this lets you do. You can have simple one-to-one messaging, like sending a credit check request to a single specialized service. You can do one-to-many, like broadcasting a price drop announcement to all of your regional inventory systems at the same time. For things that aren't critical, like logging a page view, you can use fire and forget. You just send the message and don't need a reply.
And of course, there's the classic request reply you see all the time, where a web front end asks for a user's profile and then waits for that data to come back. This flexibility is what makes this architecture so useful in the real world. All right, we've covered a lot of ground, a lot of theory. You might be thinking, great, but how does this help me build stuff with the tools I use every day? And that's exactly what this last section is about. We're going to connect the why, all this architectural strategy, to the how, the technical tools. Because understanding this foundation is the absolute key to truly mastering a tool like RabbitMQ. This right here gets to the absolute core of why we went through all of this. Without writing a single line of code, you've now built the complete mental model, the structural blueprint you need to really understand how Message Broker works. So in the future, when you hear technical terms, you'll be able to map them back to these core concepts we talked about: decoupling, the digital concierge, the black box principle, and the AMQP protocol. This is the strategic foundation that makes all the technical nuts and bolts actually make sense. So if you only remember a few things from our time today, let it be these 4 points. First, decoupling your services isn't a luxury. It is the fundamental key to building systems that are resilient and scalable. Second, just think of your message broker as a digital concierge that handles all the messy logistics of delivery for you. Third, remember the black box principle. It's what gives you the freedom to change your business without having to rebuild your infrastructure. And finally, a standard protocol like AMQP is the universal language that makes all of this interoperability possible. I want to leave you with one last thought to chew on. We live in a world that is completely obsessed with instant results and immediate responses. But what we've seen today is that by intentionally building systems that can buffer, that can absorb delays, that have the power to simply wait for a service to come back online, we create something far more valuable in the long run: resilience. So maybe, just maybe, the most powerful feature you can build into your architecture isn't speed, but patience.